If x is equal to 2, what is the value of? That expression, let's just divide through by the x squared first. So that would be x squared plus 3x. And then substitute x equals 2. So it would be 2 squared. It'd be x squared plus 3. And then the entire x squared leaves. And then that would be 2 squared plus 3. And then therefore that would just be 7. In the diagram, triangle ABC is right angled at B. AB is 10, BC is t minus 1, AC is t plus 1. What is the value of t? So simple Pythagorean theorem here. 10 squared plus t minus 1 squared. A is equal to t plus 1 squared. And when you expand this, you get 100 plus t squared minus 2t plus 1. And on that side, it would be t squared plus 2t plus 1. The t squareds go, the 1s go, and all you're left with is 100 is equal to 4t. And therefore t is 25. Suppose that 2 over y plus 3 over 2y is equal to 14. Determine the value of y. Get a common denominator. I believe that's 2y. So that would be 4 plus 3 over 2y is equal to 14. And that 7 over 2y is 14. Cross multiply and we get 7 is equal to 28y. And therefore y would be 7 over 28. Which reduces to 1 over 4. In a sequence with 6 terms, each term after the second is the sum of the previous 2 terms. If the fourth term is 13 and the sixth term is 36, what is the first term? 1, 2, 3, 4, 5, 6. So let's just say that's A and that's B. Then according to the question, after the second term, it'll be the sum of the previous 2, so that'll be just A plus B. Then this guy will be the sum of the previous 2 terms, which looks to me like A plus 2B. And then this is the sum of the previous 2 terms, which is 2A plus 3B. And then finally, that is the sum of the previous 2 terms, which is 3A plus 5B. So we are given the fourth term, which is this one, and the sixth term. So from that, we get the equations A plus 2B is 13, and 3A plus 5B is 36. And now we just have to solve those. What are they asking us for? The first term. So they want us to figure out A. Okay, not a problem. I guess if I take the first equation and multiply it by 3, that'll make it 3A plus 6B is 39. And then if I subtract those, that would be 6B minus 5B is B, and then 39 minus 36 is 3. And then to get A, I just substitute it back into there. So that's going to be A plus 2B, which is 6, is 13. So therefore, A would be 7. For some real number r not equal to 0, the sequence 5r, 5r squared, and 5r to the power of 3 has the property that second term plus the third term equals the square of the first term. So let's put that in an equation. The second term, which is 5r squared, plus the third term, which is 5r to the power of 3, is equal to the first term squared, the square of the first term, so 5r all squared. So that is the equation according to the sentence in the question. So this is going to be 25r squared. 5r, this side doesn't change for now. And then let's see what I can divide through by. I can divide through by a 5r squared, right? I'm just trying to think the best way to do this. So that's going to be 1 plus r is equal to 5. Is that it? Somehow when it's too simple, it kind of makes me judge myself. So then r is 4. Okay. Works for me, as long as it's not 0. And then the last one, Jimmy wrote 4 tests last week. The average of the marks on the first, second, and third is 65. The average marks on the second, third, and fourth is 80. His mark on the fourth was 2 times his mark on the first. Determine the mark on the fourth. Okay. So let's just say his tests are A, B, C, and D. Those are the 4 tests. So his mark on the fourth test was 2 times his mark on the first test. So D is technically equal to 2A, according to that sentence. Okay, now let's work with the rest of the question. The average of his first, second, and third. So A plus B plus C divided by 3 is 65. So that means A plus B plus C would be 65 times 3. And then the other sentence, which is the average of his second, third, and fourth, is 80. So B plus C plus D divided by 3 is 80. So that means B plus C plus D would be 80 times 3. Okay, and what are we trying to figure out? Determine the mark on this. So we're trying to figure out D, basically. Find D is our goal. Okay, so this is my one equation, second equation. Let's just call this equation 1. Let's just call this equation 2. So how about if I do, what do you want to do here? 2 minus 1? I think that'll be a pretty good. So that'll be B plus C plus D minus A minus B minus C. And that'll be 80 times 3 minus 65 times 3. So if I factor out a 3, it's 80 minus 65. So that's 15 times 3, 45. And on this side, let's see here, the B's go, the C's go, so all you're left with is D minus A. But D is equal to 2A, so that's very helpful. So I can just put 2A here, minus A is 45, so that means A is 45. And therefore D, which is 2A, would be 90. The graph of the equation y is equal to r times x minus 3 times x minus r intersects the y-axis at 0.48. What are the two possible values of r? So let's substitute that into that equation. Y is 48, and then x is 0. So that's going to be r times 0 minus 3 times 0 minus r. Okay, so that looks like 48 is equal to minus 3 times minus r, which is 3r, and then r, so 3r squared. Yeah. Okay, divide through by 3, and we get r squared is 16, and therefore r would be plus or minus 4. And those are the two values, plus or minus 4. A bicycle costs B dollars before taxes. If sales tax were 13%, AIME would pay a total of, that is $24 higher than if the sales tax were 5%. What is the value of B? All right, so let's think of the algebra here. 1.13B, which is with the sales tax of 13%, and subtract from that 1.05B, which is with the sales tax of 5%. That difference is 24. So that is the interpretation of the sentence into a math formula. So that looks to me like 0.08B is 24. And therefore, when you calculate this, it'll be B is 300. Part C, the function f has the following properties. F at 1 is 3, f at 2n is f at n all squared, and f at 2n plus 1 is 3 times f at 2n. What is the value of f at 2 plus f at 3 plus f at 4? All right, so f at 2 plus f at 3 plus f at 4. I guess we have to do this one step at a time. So here we go. Well, f at 1 is already given. That is 3. Okay, so let's try f at 2. But how do I get f at 2? I would have to set n equals 1 for that guy. So that would make it f at 2 times 1, which is f at 2. And that will be f at 1 all squared. And since f at 1 is 3, that's 3 squared, which is 9. So the 9 goes here. Okay, that was pretty quick. Let's try, well, obviously f at 3. So which one am I going to use? I'm going to use this one to get f at 3, and that's when m is equal to 1. That would be 2 times 1 plus 1, which is f at 3. And then that would be 3 times f at 2 times 1. So like that. Now f at 2 I just got was 9. So that would be 27. So 27 goes here. And then now obviously I have to figure out the f at 4, and I'll use this guy when n is equal to 2. So that would be f at 2 times 2, which is 4, would be f at 2 all squared, and f at 2 is 9, so it would be 9 squared, which is 81. And there you go, 81. So when you add up those numbers, 9 plus 27 plus 81 is 117, and that is the answer to the question. In the diagram, AB is perpendicular to CD, CP is perpendicular to AD, and N is the point of intersection of AB and CP. Also, ADB is 45, AB is 12, CB is 6. What is the area of APN? All right, so a lot of angle chasing here. I'm just trying to think what's the right way to approach this. Okay, well, let's just label it first. This is 6 here, CB. AB is 12. I don't want to label that. That's going to make it messy. But ADB, that's 45. So that's 45 right there. And then therefore that would be 45 also, since that's 90 degrees. So that is sort of starting point. Let me see if there's any other piece of information. AB is perpendicular. Okay, we got that. CP is perpendicular. We got that. N is the point of intersection. Okay. ADB is 45. AB is 12. Okay. If that's 45, then this angle in here is 45 also. So if AB is 12, then that means BD is 12 also. Because therefore, since it's 45 and 45, that means ABD, that triangle, ABD is isosceles. And since it's isosceles, the two sides would be the same. Okay. Anything else? CB. Well, this is a right angle right here, so therefore that's 45 degrees also. So therefore another isosceles triangle, NB would also be 6. And since AB is 12, AN would be 6. Okay, so I think that's about as... They're all basically isosceles triangles of the form 45, 45. You see what I mean? They're all like that. Well, let me draw a little bit bigger here. That was too small to see. So they're all of the form like this. Well, that's 45. That's 45. This is a right angle, and therefore those are isosceles. So that's sort of the trend here. And what are we trying to figure out? What is the area of APN? Oh, that little guy. Okay. All right, so as long as we can figure out the area of APN, triangle APN would be 1/2 base times height. And since that's another isosceles triangle, let's just call that x. So it'd be x times x, so it'd basically be x squared over 2. Okay. So how do we figure out x? I think we have to use a bunch of Pythagorean theorems here. So the first one, well, it doesn't really matter. Let's just use CP squared plus PD squared is equal to CD squared. Now CP and PD would be equal since it's an isosceles triangle. So this is really just PD squared times 2, and CD is 18, right? So PD squared would be 18 squared divided by 2, which is 162, and therefore PD would be the root of 162. Okay, what's the next thing you want to do here? Let's see. Let's use the triangle ABD. I think that will help. And that triangle using Pythagoras, AB squared plus BD squared is equal to AD squared. And since that's also isosceles, well, actually, we already know that. These are both 12s, so I don't even need to worry about identifying that. It's already been identified. So that's 288 is equal to AD, the square root of 288. So then finally we can get AP, which is really what we need. AP looks to me like AD minus PD. And then that would basically be, my AD is root 288, my PD is root 162, and then when you convert these to mixed radicals, it's 12 root 2 minus 9 root 2, so that's 3 root 2. And that AP is what I've denoted as x. So then you could just go back here and plug it in, so that's basically 3 root 2 all squared divided by 2. And that looks like 9 times 2 would be 18, and 18 divided by 2 would be 9. So the area of that triangle is 9. Part B. In the diagram, the line with the equation y is equal to minus 3x plus 6 crosses the x-axis at A and the y-axis at B. Suppose that m is greater than 0, and that the line with the equation y is equal to mx plus 1 crosses the y-axis at D and intersects the line with the equation y is equal to minus 3x plus 6 at point C. If O is the origin, the area of ACD is 1/2 the area of ABO. Determine the coordinates of C. Okay, hopefully I can label this without making the diagram too messy. Let's see, I'll just increase it a little bit. Okay, let's see how much I can label first of all, based on what's given in the question. Well, first of all, y is equal to minus 3x plus 6. And that is which line? That's this line, right? Yeah, that's... So let's just... what do I do here? Let's just get the intercepts. That should work. So when x is 0, y is 6. So that means that b is 0, 6. And then when y is 0, that means that x would be 2. So that means A is 2, 0. Okay, that's a pretty decent start. Okay, what's next? Well, let's use this sentence here. ACD, the triangle ACD, is half the area of triangle ABO. Okay, so ACD... Okay, well, that one I have no idea what it is, but ABO, that's fairly straightforward. This ABO would be 1/2 base times height. The base obviously is 2 and the height is 6. So that is 3. So this is 3. ACD. So let me just put that 3 in there. That triangle has an area of 3. Okay, that's pretty good. Okay, so the next thing I'm going to need is to work with this line, y equals mx plus 1. And that is, which line is that? That's this one. That line. The one that goes through D and C, correct? Yeah. Okay, so that line and this line, that one, the y equals minus 3x plus c, they intersect at C, correct? Yeah. So then obviously if I set them equal to each other, that will help me try to figure out that coordinate. So mx plus 1 is equal to minus 3x plus 6. Okay, so let's work with that here. Let's put everything on one side, plus 3x. And then that would be 5. And then that would be 5 over m plus 3 is x. So that the coordinates of C, the x coordinate looks like 5 over m plus 3. And then the y coordinate, well, obviously I'll need the y coordinate. I can plug the value of x into either one of these. I'll just plug it in there. So y is equal to m times x, which is calculated as 5 over m plus 3 plus 1. So that's going to be y is equal to 5m over m plus 3 plus m plus 3 over m plus 3. So that looks to me like 6m plus 3 over m plus 3. 6m plus 3 over m plus 3. Okay, so 6m plus 3 over m plus 3. Okay. So I think now we can get to the final step. And what is that final step? I'm going to have to figure out the coordinates of D. D is using this line, y equals mx plus 1, when x is 0. When x is 0, y is 1. So 0, 1 are the coordinates for D. So the triangle, that little guy, AOD, that is 1/2 base times height. The base is 2, the height is 1, so that's 1. So I'll just put a 1 there. And then, let's see here, what's the next step? The BCD, I think, would be the next step. The entire triangle AOB, that was 1/2 base times height, which is 2 times 6. So that was 6, right? So we already got 3 and 1, so that means this guy would be 6 minus 3 minus 1, so this would be 2. that BCD triangle. So the triangle BCD would have an area of 2. Okay, and I think we got it. So now we just have to calculate the height. So I'll just draw a little perpendicular line here. That red line sort of represents the height of that triangle BCD. So therefore the area of BCD would be 1/2 base. The base is BD, and then the height is that red line, but that red line is really the x-coordinate of C, correct? So it would really be 5/m plus 3. Yeah. So BCD we know is 2, 1/2. BD, from B to D is going from 1 to 6, right? So that's 5. And then this is just 5/m plus 3. Okay, we got one variable, so we can solve this now. So let's see, this will be 4/5 is equal to 5/m plus 3. So 25 is equal to 4m plus 12. So 13 is equal to 4m. So that means m would be equal to 13/4, which is approximately 3.25. It is 3.25. Okay, so what are we trying to figure out? Oh, the coordinates of C. Well, here are the coordinates of C, so I guess I just have to plug 3.25 into here. And let's do that. So m is 3.25. And if I plug that into there, the first one will be 5/6.25. And then this would be 6 times 3.25 plus 3 over 3.25 plus 3. And therefore this crunches out to, I believe, 0.8. And this one calculates to 3.6. So there we go. Finally, after all that, we get the coordinates for C, which is 0.8 and 3.6.